Dart School presents Compound Interest 2. A concept closely related to compound interest is nominal and effective annual rates of interest. Let's say you invest an amount of 100 Rand at an annual compound interest rate of 12%, compounded monthly. Now what does this mean? It means that the calculation is done at the end of every month, and the interest for the next month is calculated on the amount accumulated at the end of the previous month. In the formula for compound interest though, remember it's going to be amount is equal to the initial amount invested times 1 plus the rate of interest. If you have it as a percent, don't forget to divide it with 100 to turn it to a decimal, raised to the n, where n is the number of times this is compounded. The calculation is done. Now in this case, because this is compounded monthly, that means the calculation is done at the end of every month. The rate is going to be the annual rate divided by 12. There are 12 months in a year. And n, although a 1 year period, is going to be 12, because the calculation is done 12 times in 1 year. So the amount is going to be 100 times 1 plus R is 12. 12 over 12 is 1. So this part is 0.01 raised to the 12, which turns out to be 112.68 Rand. And if you subtract the initial amount deposited or invested, the interest is 12.68 Rand on 100 Rand, which is equivalent to 12.68%. This 12%, the rate given, is called the nominal rate of interest. Whereas, effectively, if we are doing that every month, we are getting an annual interest of 12.68%. This is the effective rate of annual interest. Let's now try and figure out the relationship between the effective and the nominal rates of interest. If we have an initial amount of P deposited, and then the effective interest is IE, I for interest, E for effective. So P plus the effective interest, that's the amount that's accumulated, and that's equal to the initial amount deposited times 1 plus the nominal rate of interest divided by 100, of course, if expressed as a percentage. More importantly, times n raised to the nth power, where n is the number of times it's done in 1 year. So if this is the nominal rate of interest annually, you got to divide that with n to find the rate of interest to be applied for each period. And because it's being done n number of times each year, we want to raise it to the nth power. I hope the formula makes sense. Now the effective interest is going to be P times all of that 1 plus IN over 100n raised to the n minus P. And if you divide this with P, that gives you the annual effective rate of interest. Let's call it RE. This time this is the rate. This is the interest amount, the amount in Rand, and this is the rate. So this is going to be equal to all of this divided by P. You divide this side with P, you got to divide the other side with P as well. So the rate is equal to P and P and P, these three P's would cross off. The common factor on the numerator crosses off with the P on the denominator. We have 1 plus the annual nominal rate divided with 100 times n, the number of times it's done in a year raised to the n minus 1. So given the annual nominal rate, this is the annual nominal rate, you can find the effective rate using this formula. And just so as you do not get confused, this is the actual interest. This is the actual interest. So it's essentially a certain sum of money, whereas this RE is the rate. Now what if you want to go the other way? That is, find the annual nominal rate given the effective rate. So we are going to solve for this in terms of this. Our first job is to add 1 to both sides of the equation. So we have 1 plus IN, that's the annual nominal rate of interest, over 100n raised to the nth power is equal to the effective rate RE plus 1. This is raised to the nth power, therefore we are going to take the nth root or raise both sides to the 1 over n. Raise this to the 1 over n and do the same on the other side. That means we have 1 plus IN over 100n is equal to RE, the effective rate, plus 1 raised to the 1 over n, where n is the number of times the calculation is done every year. Take the 1 on the other side, meaning subtract 1 from both sides. You get IN over 100n is equal to the effective rate plus 1 raised to the 1 over n minus 1. Now this IN over 100 is nothing but a decimal number, the rate expressed as a decimal. And if you divide that with n, it gives you the monthly nominal rate. If you want to find the yearly nominal rate, you got to multiply this answer with n. Let's do a couple of problems. We need to convert an annual nominal rate of interest of 11% to annual effective rate of interest. So essentially, it's an application of this formula out here. The effective rate is equal to 1 plus the annual nominal rate expressed as a decimal divided by the number of times it's compounded in a year raised to the same number minus 1. So we have RE, the effective rate of interest, is equal to 1 plus IN over 100 n raised to the n minus 1. We know IN, that's 11. We know n, that's 12, assumed the compounding is done monthly, every month. So therefore this is going to be equal to 1 plus 11 over 100, that changes that 11 to a decimal point 11, times 12, assumed it's being done monthly, raised to the 12 minus 1. This is going to be equal to 1 plus 0.0092 raised to the 12 minus 1, which is equal to 1.116 minus 1, which is equal to 0.116. Therefore, the effective rate of interest is, multiply this with 100 because this is a decimal, you want to express that as a percentage. Move the decimal point 2 places over to the right, 11.6%. So 11% annual nominal interest rate turns out to be effectively equal to 11.6% if the compounding is done at the end of every month. Let's do another one. This time it's just the other way around. We are given an annual effective rate of interest of 11% and we want to change it to a monthly nominal rate of interest. So this time It's about applying this formula out here. Given the effective rate, find the nominal rate. And because you want to find the monthly rate, you want to keep the n over here. If they asked for the yearly nominal rate though, you would move the n on the other side, that is multiply the answer with n. We are not going to do that. We are going to keep that n over here. So that we have, our answer is going to be RE plus 1 raised to the 1 over 12 minus 1. And that will give you a decimal answer for the interest. If you want to change it to a percentage, just multiply that with 100. Let's go. So IN over 100N is equal to RE plus 1 raised to the 1 over 12 minus 1. Well, RE is given to be 11%. Change that to a decimal. It becomes 0.11 plus 1 raised to the 1 over 12 minus 1, which is equal to 1.11 raised to the 1 over 12. That's the 12th root of 1.11 minus 1. Either you need to use a calculator or the logarithmic tables to do this, to find this out. Nobody is going to expect you to do this mentally. Okay, so this is going to be equal to 1.009 minus 1, which is equal to 0.009. And that is the interest expressed as a decimal. You want to change it to a percentage, times with 100, which means move the decimal point 2 places over to the right. This is 0.9%. So the annual effective rate of interest of 11% turns out to be a monthly nominal rate of interest of 0.9%. If you're asked to find the yearly nominal rate of interest, you would times this answer with 12, which will give you 10.8%, which is less than 11%. That's what you would expect, right? The effective rate will be more than the annual nominal rate of interest. Hope that helps.